In this first video, I will be covering what robotics is capable of doing, as well as the components of the spike prime kit that we will be using. So robotics simply is creating a machine, and this machine can be semi-automated or automated. And automated means that it is able to do all of its actions on its own without a human controlling it, while semi-automated means that a human has some influence over the robot's actions. So for example, if you've driven a car with a remote control, that would be a semi-automated robot, whereas a rover on Mars operating independently without any human input would be an automated robot. And robots can move, make things, and perform other repetitive tasks. So the key here is that they're able to perform things that are repeatable. So for example, with this Rubik's Cube, a couple motors are turning the sides on the Rubik's Cube, and that is a repetitive task. So now I'm going to talk about some of the components that the Spike Prime kit comes with. So to start off, the robot kit comes with a brain, basically, which is able to control the robot. And this has all of the information that the robot needs to function, as well as a source of power to control the motors and sensors and things like that. So in order to provide power and information to motors and sensors, you need wires, and those wires are plugged in where these red arrows are pointing. And there are 6 of these available, which means that you can connect 6 motors or sensors. So it doesn't need to be 3 motors and 3 sensors. You could, in theory, connect 6 motors to this brick. And the brick itself is a central command center of the robot. And you can think of it as something similar to the human brain. And what it does is it interprets the program that you load it with, and it converts it to computer code, which it can then provide to motors and sensors to have them move and receive input. And it sends and receives signals between the motors and the sensors. And this obviously is the most important part of the robot because it is controlling everything that is happening. So if you don't have a brick, you can't have the robot do any tasks because there's nothing to control it. The motors make the robot move, and all these motors have something inside that allows them to rotate, and that causes this part of the motor here to rotate. And these are usually attached to wheels or other objects, and that causes that to move in a rotating motion as well. And so some things that you can attach to these are wheels, other attachments, and gears, which can in turn move other things. And Spike comes with 2 motors, large motors and small motors. Large motors provide you with more torque since they are larger and have more power. And torque is basically a measure of strength. So if you're pushing a very heavy thing, you need a lot of torque, whereas small motors provide you with more speed but less torque. So for example, you might be pushing something very fast, but if it's heavy, you might not be able to push it because you don't have the torque to push it. So small motors are capable of pushing things very fast or rotating very quickly, but once you tell them to rotate something that's heavy, they begin to struggle. Whereas large motors, they won't have an issue turning under a lot of weight, but they may not be capable of rotating as fast as a small motor. And because of this, on heavier robot designs, large motors are primarily used for the wheels because the wheels are holding a lot of weight from the robot. So they're able to provide the necessary amount of torque in order to move the whole robot. And so wheels are attached to those motors and they rotate along with the motors. So if the motor is making one rotation, the wheel is making one rotation as well. And one rotation of the motor is going to result in the wheel traveling its circumference. So a circumference is the measure of the length around the circle. So if you have a wheel with the circumference of 5, then the motor is going to travel 5 centimeters for each rotation of the motor. In this video here, this robot moves a certain set distance in order to capture the block. So for the wiring is able to transmit information between external components and the controller. And in our case, those external components are going to be things like sensors and motors. And good wiring prevents the robot from catching onto obstacles when you're executing the program. So you have wiring all over the place that is like extending out of the base of the robot, then it can potentially catch on to other objects and prevent the robot from moving forward. But if you wrap it around other components or thread it in between pieces, then the wires will be closer to the base of the robot and they won't be able to catch on to potential obstacles in your way, and your program will be able to run as intended. Lastly, we have sensors, and these provide input to the controller of the robot. And the robot is able to use that input to control future actions, which you usually decide in your program that you load onto the robot. And these offer various functions, one of them being a method to align the robot, as well as follow lines and detect touch, as well as detect distance. And the three types of sensors included with Spike are the color sensor, the touch sensor, as well as the ultrasonic or distance sensor. So the color sensor is the one in the middle here, and it detects color. And the touch sensor detects touch. You can detect if this front part here is pushed and let go, as well as whether it's being held down. And this ultrasonic sensor is able to detect the distance away from a certain object. And inside the brick, there is a gyro sensor, which is able to detect the angle that the robot is at. So if the robot is turned 90 degrees, then the gyro sensor would say that the robot is at a 90-degree angle. But if it's straight, it'll say it's at a 0-degree angle. And this can be used to program the robot to go in a straight line, as well as make accurate turns. The gyro sensor also comes with an accelerometer, so it's able to detect the speed at which the robot is changing angles, which can also be used if you're trying to program a two-leg walking robot. And so that's just a quick introduction to the components in the Spectrum kit. And in the next video, we will be talking about the base robot,